Example comes out of section 11.1 permutations. So this question brings us back to our arranging letters in a word. We're asked how many ways could you arrange all the letters in orange if there are no restrictions. Well, no restrictions. I look at the letters carefully. I've got 1, 2, 3, 4, 5, 6 letters all together. They are all different letters, which makes this fairly straightforward, and that it's just going to be 6 factorial, or 6 P6, 6 objects arranged in 6 spaces, 6 times 5, 4, 3, 2, 1. That answer, 720 arrangements. Now, if they say the first letter must be R, basically takes R out of your equation. You might as well be arranging all letters in O-A-N-G-E, because the R, there's only one way. If I draw my spaces 1, 2, 3, 4, 5, 6, and say this one has to be an R, there's only one way to put an R there. And you now no longer have an R to put anywhere else. So you have 1, 2, 3, 4, 5 letters. So 5, 4, 3, 2, 1. Or if you prefer, you could say 1 times 5p5 or some other way of writing that. But you're going to get only 120 arrangements this time. Far fewer. And this is a common theme you should run into, is that the more restrictions you put on something, the less arrangements you're going to have. Now, the vowels must be together is an interesting question. You run into this one actually quite often, even on diploma exams. First of all, you need to know what vowels are. So hopefully everybody's got A, E, I, O, U as your vowels. Don't worry about sometimes Y. They'll stay away, and I'll stay away from getting that picky about something. So in this word, you don't have to worry about that anyway. The vowels we have are O, A, and E. And the remaining letters are R, N, and G. So we have 3 vowels and 3 consonants here. These vowels, we're basically going to treat them as one object for a moment here and say, okay, well, that now I would be saying I can put the vowels at the front, at the back, in the middle, and so really I just have 4 factorial ways of arranging these 4 objects, 4p4. But then if you you correctly point out that OAE don't have to be in the order OAE, they can be OEA, EAO, etc. There are 3 factorial ways of doing that. So I have to take this answer and multiply by 3 factorial. So 4 factorial times 3 factorial ends up being our answer. And what is that? 24 times 6, which is 144 arrangements. So it would have the vowels together. This next example seems awfully similar. We're given a different word here, folders, 7 letters this time, but we're asked how many arrangements would not have the vowels together. First time I tried doing questions like this, I got super complicated, tried to draw 7 spaces, 2, 3, 4, 5, 6, 7, say, well, if there's a vowel here, there can't be a vowel here, and if there's a vowel here, there can't be a vowel here, and tried to do all these possibilities, and I got myself very confused by doing it. A much simpler way of doing this is to say the total possibilities here, the total arrangements of the word folder is just going to be 7 factorial, or 7p7, which is 5,040 arrangements. No repeated letters. So folders has 1, 2, 3, 4, 5, 6, 7 letters, and that's it. The total with the vowels together, so with vowels together, we would do similar to how we did above. In this case, we only have 2 vowels. We're left with F, L, B, R, S. 1, 2, 3, 4, 5, 6 objects total being arranged, and then OE can also be EO. So there's 2. 6 factorial times 2 factorial is how many ways we can get the vowels together, which ends up being 1,440. Really, in this question, you either have the vowels together or you don't. And so I've done everything but find the answer to this question, and the reason why I did it this way is if I take the total arrangements and I just subtract the number of arrangements with the vowels together, I should have the number of arrangements with the vowels not together. And that's exactly how I would suggest doing a question like this. Far more direct. 5,040 minus 1,440 equals 3,600 arrangements that would have the vowels not together. Any other way I've tried got too confusing before I ever got to an answer that made sense.